This is lesson 3.3, graphing linear functions. Your objective today is that you can graph linear functions. A term that you need to know is function notation. And function notation is a way that we write, and maybe the way that I'm going to say this is this shows the input and the output at the same time. It does not mean multiplication. And the reason I'm saying that it does not mean multiplication is the way that this function notation looks. And what this looks like is it's going to look like this. And we say f of x equals something. And what you can imagine, and maybe this is like 3x plus 2. And what you could imagine is that this y, this is how I could also write it, is y equals 3x plus 2. However, in function notation, we don't use this. We use this f of x. And so, for kind of your sake, you can think of f of x as the same as saying y. Let's do a couple problems with this, and I think you'll probably get it. So in the first one, we're going to do in examples 1 through 6, we're going to evaluate the function when x equals -4, 0, and 2. And it's going to help us, this function notation is going to help us kind of keep everything in line and kind of tracked so that then we can solve everything and show our answers kind of easily. So the first equation is f of x equals -x plus 4. Whenever I do function notation, what I'm going to do is instead of x, and this kind of applies to any time that you do any equation, everywhere that we see x, we're going to set our first value. So we're going to set -4. So I'm going to go, okay, f of -4 equals negative, and then put in parentheses, -4 plus 4. And so I'm going to leave this f of -4 the whole time, because that helps me remember which answer I got. This negative and a negative make a positive 4, and positive 4 plus 4 is 8. I'm going to draw a line just to kind of help myself whenever I come back to my answers. Now I'm going to do f of 0, and I'm going to say -x, or oops, not -x, because the x is now 0. Anytime I'm putting it in the actual equation, I'm going to put it in a set of parentheses. So plus 4. And so f of 0 winds up being 4. Alright, now I'm going to do f of 2. And that's going to be negative, and put it in parentheses, 2 plus 4. And so f of 2 equals -2 plus 4 is 2. And so those are my 3 answers. 1, 2, 3. Let's do another one. Let's do number 2, where we have g of x equals 5x. Alright, and I said does not mean multiplication. What I meant by that is I don't mean multiplication of the g and the x. And so what this is, alright, I'm going to do my first one. I'm going to do -4. I am going to, however, do some multiplication on the outside here, and this is the actual equation. So g of -4 equals 5 times -4 is -20. Alright, now let's do it when I have 0. 5 times 0. So g of 0 equals 0. F of, or oops, not f. I was looking at the last one. G of 2 equals 5 times 2. And so g of 2 equals 10. So number 3. H of x equals 7 minus 2x. So I'm going to start with h of negative 4. So 7 minus 2 times negative 4. H of negative 4 equals negative 2 times negative 4 is positive 8, plus 7 is 15. H of 0, 7 minus 2 times 0. So h of 0 equals 7. H of 2 equals 7 minus 2 times 2. So h of 2, negative 2 times 2 is negative 4, so 7 minus 4 is 3. Let's do number 4. S of x equals 12 minus 0.25x. So S of negative 4 equals 12 minus 0.25 times negative 4. So S of negative 4 equals 12 minus 0.025 times negative 4. Negative 0.025 times 4 is 1. Negative and negative make a positive, so this turns into 13. S of 0. So I do 12 minus 0.25 times 0. So I get S of 0 equals 11.5. S of 2 equals 12 minus 0.25 times 2. 2 of those make negative half. Oops, I messed up. This shouldn't say this. I was doing the next one. This one. This should say 12. There we go. So S of 2 equals, that's a half, so this turns into 11.5. There, that one's right. Okay, number 5. T of x equals 6 plus 3x minus 2. So if I do t of x, or not t of x, t of negative 4, and that equals 6 plus 3, instead of x, I say negative 4, minus 2, t negative 4. Let's see, so this winds up being 6. 3 times negative 4 is negative 12, so minus 12 minus 2. So t of negative 4 equals negative 12, or 6 minus 12 is negative 6, minus 2 is negative 8. That's the first one. T of 0 equals 6 plus 3 times 0 minus 2. So t of 0, that's 0, so 6 minus 2 is 4. You're at that 4, so if someone's just looking at this, they can understand what that says. There we go. And let's do t of 2. T of 2 is 6 plus 3 times 2 minus 2. So t of 2, 3 times 2 is 6, plus 6 is 12, minus 2 is 10. Number 6. U of x equals negative 2 minus 2x plus 7. So I'm going to do u of negative 4 equals negative 2 minus 2 times negative 4 plus 7. So u of negative 4. Let's see, that makes the negative 2 and the 7 make 5. Negative 2 times negative 4 is positive 8. So u of negative 4 is 13. Alright, let's do u of 0. So negative 2 times 0 plus 7, that's 0. So u of 0 equals 5. Alright, let's do one more. So u of 2 equals negative 2 minus 2 times 2 plus 7. So u of 2, again, that makes 5, so I know that. So minus 4. So u of 2 equals 1. Alright, so the way that we kind of can apply this to a little more real world is kind of filling in some of the gaps, especially like in word problems. And so in the word problem for number 7, we say, let n of t be the number of DVDs you have in your collection after t trips to the store. Explain the meaning of each statement. So so I'm going to write this out just so really kind of quick. So n of t equals DVDs, and t equals trips to store. So if I said n of 0 equals 8, what this tells me is I've taken no trips. So no trips, we have 8 DVDs. That's kind of what we started off with. If I do n of 3, oops, not 2, of 3, equals 14, this tells me 3 trips. After 3 trips, I have 14 DVDs. And so after 3 trips, I have 14 DVDs. All right, let's go to number 8. Find the value of x so that the function has the given value. So this is kind of finding the answer and finding how we get the answer. So in this case, we have b of x equals negative 3x plus 1. Then we have this semicolon. This separates what's going on, and it says b of x equals negative 20. Now at first this looks pretty confusing. You're like, man, how do I even start? But what we should realize is this is telling us expressly what b of x is. And so instead of b of x, I can actually put in negative 20. So I have negative 20 equals negative 3x plus 1. And this should look kind of familiar, like something that we've done before. And so I subtract 1 from both sides. And I say, okay, I got negative 21 equals negative 3x. Divide both sides by negative 3. And I get, I get 7. There we go. 7 equals x. And that's what we're looking for. We're looking for the value of x so that the function has this given value of negative 20. Let's do number 9. Number 9 says r of x equals 4x minus 3. R of x equals 33. So what I'm going to do is I'm going to take this and I'm going to plug it in for r of x. And so I have 33 equals 4x minus 3. And now again, this is something that we've done before. So I go 33 plus 3 is 36 equals 4x. I divide both sides by 4, and I get 9 equals x. And that's my answer. If you think you got it, go ahead and give this a pause, and I'm just going to keep working though. Go ahead and pause it and try it on your own. Alright, so if I have m of x equals negative 3 over 5 x minus 4, m of x equals 2. Anywhere I have m of x, I'm going to take that and I'm going to plug it in. And so I get 2 equals negative 3 over 5 x minus 4. Starting off, I'm going to add 4 to both sides, and I get 6 equals negative 3 over 5x. To get rid of negative 3 over 5, I'm going to multiply by negative 5 over 3 on both sides. You could separate those into two different things. You could first multiply by 5 and then divide by 3, but this will work as well. And so what I get here is negative 5 times 6 is negative 30, and divide that by 3, I get negative 10. So negative 10 equals x. All right, now number 11. If I have w of x, and that equals 5 over 6x minus 3, and w of x equals negative 18, I'm going to take my w of x, plug it in, and so I have negative 18 equals 5 over 6x minus 3. Going to add 3 to both sides, and so I have negative 15 equals 5 over 6x. I'm going to multiply both sides by 6 over 5. And I'm kind of going to do the division first, because negative 15 divided by 3, or by 5, is negative 3, and negative 3 times 6 is negative 18. Which is kind of cool that it winds up being the same thing. Pretty neat. Alright. Now it asks us to graph the linear functions. So for number 1, we have r of x equals 4x. And you can treat this like we normally would treat a linear value. And so if I have my graph here, I'm going to plug in values for 0, or for x. The first one I'm going to start with is 0. And I might make a little rx table over here. That way I can kind of just keep track of them as I'm kind of going. I like to do, whenever I'm doing a line, I do 3 of them. So I do negative 1, 0, and 1. The reason why, those are typically some pretty easy math numbers. So negative 1 times 4 is negative 4, 0 times 4 is 0, 1 times 4 is 4. And so I know I'm going to have 1 here, 1, 2, 3, 4, 1, 2, 3, 4, and a nice totally straight line that connects those two. And it has an arrow going in both directions. Alright, let's do number 2. Number 2 I'm going to make a little bit bigger. Might see why here in a second. Because number 2 reads w of x equals 3 over 5x plus 2. And the whole way that I evaluate this is I look at this and be like, man, that's a fraction. I don't really want to deal with fractions, or if I do, I'm going to make them some easy fractions. And so my xwx table is going to look like this. It's going to be negative 5, 0, and 5. And the reason for that is that way this bottom denominator kind of gets canceled out as we're going. So this is going to give me negative 3 plus 2, which winds up being negative 1. 0 gives me 2. 5 gives me 3 plus 2, which is 5. So, negative 5, 1, 2, 3, 4, 5, down 1. 0, 2, 1, 2. 5, 5, 1, 2, 3, 4, 5, 1, 2, 4, happens to be right there, 5. And so, very straight line that totally connects all of those. Right. Let's go to number 3. Number 3 says d of x equals negative 1 over 2x minus 3. So we're going to graph this again. And again, I'm going to make an x dx table. And in this case, I'm going to use negative 2, 0, and 2. Again, I want to kind of eliminate the denominator. So when I do negative 2, I get negative 1, or positive 1 minus 3 gives me negative 2. If I do 0, I get negative 3. And if I get 2, I get negative 4. Two, 3. So negative 2 is right here. And then down 2. And then 2, 4. And straight line connecting the 2, 3. And arrows pointing in both directions. Alright, now I do number 4, which says f of x, and this is probably the most common that you'll see is this f of x, equals negative 4 plus 5 over 2x. Make my little table, or my graph. Make a table. Let's see, x, f of x. I'm going to use negative 2, 0, and 2 because of that denominator. So when I do this, negative 2 turns that into negative 5, so negative 4 minus 5 is negative 9. 0 gives me negative 4, and 2 gives me 1. So if I do this, let's see, negative 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my point. 0, negative 4, 1, 2, 3, 4. 2, 1, 2, 1. And so I draw my line connecting all of them. And that finishes lesson 3.3. Make sure you check ask your teacher for your assignment. Have a good one.